We're about to journey back in time, way back, to a lost world. I'm talking a billion years before the first dinosaur. It's a world that holds the secret to our very existence, but for the longest time, it was hidden in what everyone thought was just an empty chapter of Earth's history. This is the incredible story of the Statherian period.
Yeah, for decades, this is pretty much how science summed up nearly a billion years of our planet's past. A time of silence, of stagnation, just boring. But what if that silence wasn't empty at all? What if it was actually the quiet hum of a planet-wide revolution taking place? All right, so here's our game plan. First, we're going to completely bust that myth of the boring billion. Then, we'll look at how this was really a great assembly period, a time that gave rise to a whole new kind of life. And yep, the very first predators. We'll tie it all back to our own deepest origins, and then I'll show you how you can unlock the full, amazing story.
Okay, so first things first, how did this absolutely pivotal period in Earth's history get such a bad rap? Why was it written off as boring for so long?
So to get our bearings, we're zooming in on a 200 million year-long chapter of Earth's story. Now, to put that into perspective for you, that one period is longer than the entire time that dinosaurs roamed the Earth. And it's just one piece of a much larger era nicknamed the Boring Billion. I mean, that is a massive chunk of time to just write off. And just listen to the language people used. Stagnation, barren slump. These aren't just dry scientific terms. They're really dismissive. For the longest time, textbooks basically treated this whole era like a footnote, completely overshadowed by the flashy dinosaurs or the famous Cambrian explosion.
And here's the culprit, the smoking gun for all this boringness. Scientists looked at the geological data, specifically carbon isotopes, which kind of act as a tracker for biological activity, and this is what they saw, a flat line. For a billion years. It suggested no big climate shifts, no major spikes in life. It looked like planet Earth just hit the pause button.
But here's where the story gets really interesting, because today, scientists are looking at that exact same flat line and seeing something totally different. They're not seeing silence, they're seeing stability.
So the whole idea has been completely reframed. The thinking has done a total 180, shifting from stagnation to assembly. This era wasn't a pause at all. It was the essential period of preparation, where the foundations for all complex life were being carefully, meticulously put together. And this question, this is what's driving all the new research. It completely flips the old story on its head. What if stability wasn't a sign of boredom, but was actually the one thing life needed to pull off its most ambitious project ever? Think of it like this. Imagine you're trying to build something incredibly delicate and precise, like the world's first complex cell. You just can't do it in a chaotic workshop where things are shaking all the time, right? You need a stable environment. Well, the Statherian period was that stable workshop for life on Earth. And during this long period of calm, life was going through a soft revolution. Now, these are changes that don't leave behind fossilized bones, but they are infinitely more important. The basic blueprints for our kind of cell were being drawn up. Things like the nucleus, a little vault to protect fragile DNA, and mitochondria, these tiny power plants inside the cell. Even sex itself, the engine of genetic diversity and evolution, was likely invented during this quiet time. And all of this groundwork, all this quiet assembly in a stable world, it was all leading to the single greatest leap in the history of life on our planet. So let's meet the hero of our story, the eukaryote. This is not just any old cell. It's like a high-tech biological machine, super organized with its genetic code tucked away safely in a nucleus and all these other specialized parts doing different jobs. And here is the punchline. This is us. Every plant, every mushroom, every animal, every single one of us, we're all made of eukaryotic cells. So without the events of this supposedly boring Statherian period, none of us would be here. Our deepest, most fundamental story starts right here. Okay, so if these new, complex cells were on the scene, that leads to a really tantalizing question, doesn't it? Does that mean there were complex creatures? Were there animals swimming around? It's a natural question to ask. When we think evolution, our minds jump to strange-looking fish or ancient bugs in some primordial ocean. So what's the real story? What does the evidence actually tell us? The simple scientific answer is no. True animals, multicellular things like sponges or worms, they hadn't evolved yet. Oxygen levels were probably way too low. But that is not the end of the story, not by a long shot. Because while there were no animals, there was animality. Predation, the act of hunting and eating other life, had officially begun. We've found microfossils from this period that show single-celled organisms developing defensive spines and armor plating. And why would you do that? To avoid being eaten. A microscopic arms race had kicked off.
So this brand new, violent world of predator and prey must have been a huge driver for evolution, right? But what did it create? You might think it just led to better microscopic weapons. But it turns out, one of these failed hunts, one act of a predator eating something that didn't go quite as planned, it changed the course of life on Earth forever.
It's an incredible process called endosymbiosis. Picture this. A big predator cell swallows a smaller bacterium. But instead of digesting it, the little bacterium just sets up shop inside. And over millions of years, that bacterium became the mitochondria, the literal power plants that are energizing every single one of your cells as you listen to this. Without them, complex life just wouldn't be possible. An ancient act of predation created a partnership that powers the world.
And you know, understanding this period isn't just a fun history lesson, it's a roadmap. As we search for life on Mars or on planets orbiting other stars, we're often looking at worlds with low oxygen. While the Statherian period gives us a perfect model for how life might not just survive, but make its greatest evolutionary leaps in exactly those kinds of environments.
We've just pulled back the curtain on an era that was once dismissed as boring, only to find this quiet, world-changing revolution that shaped the future of everything. But believe me, we have only just begun to scratch the surface. What we've gone through here is really just a highlight reel of an incredibly deep and dramatic story. The full truth of what happened in the Statherian period is filled with details that are even more mind-blowing.
In our complete guide, we explore the formation of the very first supercontinent, Columbia. We'll take you for a dive into the toxic, hydrogen sulfide-filled oceans that our ancestors had to survive in. We uncover the bizarre origins of sexual reproduction, and we even discover how this ancient world is directly responsible for creating the lead that's in your car battery today. To really understand the incredible drama of how we all came to be, we invite you to explore the complete guide and unlock this lost but absolutely crucial page of Earth's history.
Hey there, time travelers. Welcome. Today, we're firing up the time machine to take on one of Earth's most misunderstood eras with a 10-question brainbuster. Your mission? To prove you're a master of deep time and uncover the secrets of our planet's quiet revolution. So, let's get started. You know, for decades, this period was basically written off with phrases just like this one. You've probably heard it called the dullest time in Earth's history, or maybe the era where nothing happened. Well, we're here to bust that myth wide open. Because what looked like boredom was actually the quiet, deep breath life took right before its greatest leap. Okay, here we go. Question 1. It's a name that you definitely didn't hear about in your high school science class, but believe me, it's one of the most important chapters in our planet's entire story. So what is it? Take a second. Think you got it? And the answer is the Statherian period. This 200 million year stretch of time was the absolute crucible, the cradle, where the fundamental building blocks of all complex life, you, me, everything, were first hammered out. I mean, let that sink in for a moment. Without the Statherian, we literally wouldn't be here. So the Statherian is just one chapter in a much, much bigger book. A huge chunk of time that got stuck with a famously misleading nickname. A nickname that, honestly, couldn't be more wrong. Do you know what it is? We are talking about a vast, almost unimaginable expanse of time. A full billion years. Yeah, and it got stuck with one of the greatest misnomers in all of science. They call it the boring billion. But as you're about to see, it was anything but. And here's the twist. The boredom was actually a feature, not a bug. Just imagine you're trying to build the most complex, revolutionary piece of machinery ever. You can't do that in a workshop that's constantly being shaken by earthquakes, right? Well, this incredible planetary stability was the perfect, quiet laboratory that life needed to engineer its greatest piece of software, the complex eukaryotic cell. Okay, let's pivot for a second, from biology to geology. Because it wasn't just life that was changing during the Statherian, the entire face of our planet was transforming. For the very first time in history, all of Earth's landmass came together in one place. What was this supercontinent called? It was called Columbia, the formation of Earth's very first supercontinent. I mean, that's a massive geological milestone, and it just brilliantly shows you the incredible scale of change that was happening during this supposedly boring time. Okay, Now let's dive deep beneath the waves of those ancient oceans, because something truly radical was brewing. A quiet revolution that was about to rewrite the rules of life on Earth forever. What was the single greatest evolutionary leap forward during this period? It was the emergence of eukaryotes. Now, these are cells with a true nucleus, a real command center to hold all the genetic blueprints. And here is the absolutely mind-blowing part. Every single complex organism you can possibly think of, from a tiny mushroom to a giant blue whale to you, we are all direct descendants of these microscopic pioneers. All right, time to switch things up. A simple true or false question. So, we've got these new complex cells showing up. Does that mean we finally have animals? Were there ancient fish or maybe some simple sponges swimming around in the Statherian seas? What do you think? True or false? And the answer is a big, resounding false. Nope. And the reason why is one of the most important rules in deep time biology. It all comes down to oxygen. See, oxygen levels back then were only about 1 to 10% of what they are today. And that's just not enough to synthesize collagen, which is basically the essential protein glue you need to build an animal body. No glue, no animals, simple as that. So, if there weren't any true animals yet, what's the big deal? Well, something else emerged. A new, fundamental, animal-like behavior. A strategy that completely changed the game and kicked off an evolutionary arms race that is still going on today. What was it? Predation, the simple dynamic of eater and eaten. This was a completely revolutionary new business model for life. Think about it. Instead of going through all the trouble of making your own energy from sunlight, you could just steal it from someone else. This new system of plunder just put evolution into overdrive. Which, of course, begs the question, who were these first hunters? If they weren't animals, then who was out there fighting these first microscopic death matches in the ancient oceans? Well, meet the planet's first predators, large amoeba-like predatory eukaryotes. Now, technically, they weren't animals, but they sure behaved like them, hunting through the water and swallowing smaller organisms whole. This right here was the true dawn of animality. So how in the world do we know any of this was happening? I mean, we can't exactly watch it unfold. What's the fossil evidence? What are the clues that give us a glimpse into this ancient microscopic arms race? The proof is in these tiny microfossils called acritarchs. See, when you look at fossils from before this period, they're pretty much all simple, smooth spheres. But right after, you see this sudden explosion of defensive armor, sharp spines, hardened shells, you name it. And really, why would you arm yourself unless you were desperately trying to avoid being eaten? These fossils are the silent testament to a new, much more dangerous world. Now, this new danger, this new reality of predation, led to one of the greatest miracles in the history of life. You could call it a failed digestion that ended up changing everything. What do we call that process where a predator eats a bacterium, but instead of destroying it, ends up forming a revolutionary new partnership? It's called endosymbiosis. It's an incredible story. A predator swallowed a special kind of bacterium, but for some lucky reason, the digestion process failed. That little bacterium took up residence inside its host, and they formed a partnership. And over millions of years, it evolved into the mitochondria, the tiny powerhouses that are fueling nearly every single cell in your body right now as you're listening to this. All right, last question. We're almost there. All of this incredible drama, the birth of complex cells, the dawn of predation, the miracle of endosymbiosis, it all took place in a very specific and very harsh environment. What was the name of this toxic, low-oxygen, hydrogen sulfide-choked ocean? It was called the Canfield Ocean. And this just brilliantly illustrates a key theme of our whole story. It was inside this harsh, toxic, and seemingly inhospitable sea that life didn't just manage to survive, it thrived. It made the single most important leap towards complexity in our planet's entire 4 billion year history. Amazing. And that's a wrap. Congratulations, you made it through the challenge. So, how'd you do? If you got 8 to 10 correct, you are a true master of deep time. If you got 5 to 7, you're a Statherian scholar with a solid grasp of this quiet revolution. And if you got 0 to 4 correct, then you're a curious explorer who's just taken the first exciting step into a fascinating new world. But the main takeaway is crystal clear. The boring billion was actually the essential assembly period for all complex life. But you know, what you've just seen here is really just a glimpse, a little teaser into the epic story of the Statherian period. We've barely even scratched the surface of the supercontinent Columbia, or the mysterious magma activity that shaped it, or the empires of bacteria that ruled its oceans. This has just been the introduction. So the real question is, are you ready for the full story?